Hello everyone, today is the session for backpropagation neural network. In the previous session I have explained about convolutional neural network as well as I have given the basic concept about what is neural network. So please refer my first video to getting the basic concept as well as to know about convolutional neural network. In today's session we are going to discuss about backpropagation neural network. Why the neural network name given? Because you know the neural network works in a similar way like a human mind works, so the term neural network given. Okay, and what about backpropagation neural network? Let's discuss in detail. Okay, suppose I am drawing a round shape. Okay, this is in neural network term, this is called as your node. Okay, you can say it neurons or you can say it node. Okay, this node, this first node is called as your input layer. Okay, again I am drawing two nodes, right? After that I am drawing one more node. Okay, this is the first node and the last node is called as your output layer. Okay, and in between input output layer, the between nodes are called, this is your between nodes between input output layer, this is called as your hidden layer. So what are the layers? Input layer, hidden layer and output layer. And one more thing, there can be more than hidden layer possible. Here I have drawn just one hidden layer, but there can be more hidden layer. Okay, so this is also your hidden layer. Okay, not just one more, there can be 100,000 of hidden layer in between your input and output. Why? The hidden layer is mainly needed for your computation, you can say your calculation purposes. Okay, so now let's move to the main structure I have drawn above. Okay, so here you can see I have drawn the structure of a neural network. This is your input layer, hidden layer, output layer. Okay, and one more thing, you can see the input layer node is connected to every and each other node of hidden layer. This is connected to the first hidden layer node. This input layer is also connected, you know, to the second node of hidden layer. This is connected to this, you know, second hidden node, and this is also connected to the first hidden node. So each layer node is connected to every other node. Okay, now what are the things you are seeing? You can see there I have two values. Okay, the two value x1 and x2 of input layer is called as my input value. Okay, this is my input I am giving. This x1 is 0.10, this x2 is 0.20. This is a simple example I am telling. Okay, these two inputs are, these are two inputs, that is 0.10, 0.20. Okay, next just see, go to the output layer. Okay, this is the output layer and here you can say 0.99. This is nothing but your target output. I want that when I give my input as 0.10, 0.20, I want my output to be 0.99. So 0.99 is my target output. Okay, and in the middle there is hidden layer. And what other things you can notice over here? You can notice that these are the edges connecting. And the edges has also some values like 0.10, 0.20, 0.05. These values, the edge values, are called as your weights. What it is called? Weights. So these are, I have named is W1, W2, W3, W4, W5. Okay, these are your weights. And what else you can notice in the diagram? What else remaining? The else is the bias. Okay, now the concept of bias is called. This is the input, hidden and output. What is bias? Okay, the bias is a very important concept in your neural network. I am explaining this with the help of a figure. Okay, suppose this is a line. Okay, this is a line. Okay, what is my target value over here? It's 0.99, right? So let 0.99 is over here. Okay, and my line is passing through this, and this value is, this is 0.50. Let the line value is 0.50. Okay, and the line is passing through the origin. What I want to reach over here, because 0.99 is my target value. So how, if the line passes through the origin, can it reach to 0.99? No. So to reach this point, the line will be in this way. So what the bias do? The bias helps in shifting the line towards left or right. This bias value helps in shifting the line and getting to the desired target value. It helps in shifting the lines from the origin and getting the desired desired target values. So that's why bias is used. Bias helps a lot in generating the desired result values and reducing your error. Okay, these are the things of basic things of your neural network. One more thing I want to discuss before going to the mathematical calculation. One more thing I want to discuss, that is, what is activation function? What is activation function? What is activation function? Okay, there are many activation function used for your in your what, in your neural network. Many activation function used. That's are like I can say sigmoid. Just remember the names. I will explain each and everything. Sigmoid activation function, tanh activation function, ReLU, and softmax. And others are also there. Okay, these are some basic activation function used. Okay, so these functions are used in your neural network while generating your output. Suppose this is your hidden layer. Okay, I am giving an input to this. While generating the output from a node, these activation function is used. Suppose this is your output layer. Okay, this is the input given. To generate the output, I will use a activation function. Whenever you generate an output, you need to use your activation function. As the name suggests that activation, something is activating. Why I need to use activation function while generating the output? Because as the name suggests, what is activation? It is activating the desired node, the desired neuron. It is firing the desired neuron. Okay, I am explaining you through a very example. I am explaining you. Suppose this is my output layer. Okay, I am giving bird image as my output. I am feeding bird image as my output. Okay, this layer tells that this is bird. This is a node for bird image. This is the output layer. Okay, this is the output layer. This is the output layer. This node tells that it is 0.99% bird. Okay, this layer tells that it is cat. This layer tells it is cat. Okay, and this layer tells it is dog. These are the three output layers. Okay, first telling me it's bird, second cat, second dog. Okay, the three input images can be fed. So what I am feeding right now, I am feeding bird, not cat, not dog. I am feeding bird. So which node should be activated right now? This node will be activated with 0.99% that it is bird. This node will be activated, right? So activation function helps in activating or firing these nodes. It understood. Okay, it will shift the values 0.99%. It will make this node value 0.99%. okay, 0.99% means this is your target. So you understand, okay, this node is activated, and what is the outcome of this node? This node is bird. So this node is activated. So it helps in firing the correct or the desired node. Okay, these two are wrong. Okay, because I am feeding a bird. Okay, so this node gets activated. Okay, so now you understand why activation function is used. It's used to activate or fire the desired, the correct node. Okay, now let's move to the, now you have understand the basic structure, all the terminologies behind neural network. Now let's move the actual computation of neural network with the help of these values. Okay, right now actual how the computations are done I will explain you. And one more thing, this is very example in your exams. Okay, you may get a exam, in your exam you get a question. Okay, you will be given such values and you will be asked to compute the final error value. Okay, to reach this target you will be asking. So it's very also important for your exam purposes. So first of all, what I will do, first my first part is I have got two inputs 0.10, 0.20. My first task is to calculate the input values for my hidden layer, that is hidden node, that is H1. Okay, then I will calculate the input values for H2. Okay, after that I will calculate the output value for H1 and H2. Okay, after this I will calculate the input values for your output layer, that is O1, and again I will calculate the output value for O1. Okay, this is the, sorry, first I will calculate input value of O1, then I will calculate the output value for O1. So first let's calculate the input value for H1. And how the things are calculated, you just notice the H1. This is your H1, okay, node you notice. And what are the edges coming to it? What are the edges coming to it? This is the first edge coming to it, this is the second edge coming to it, and this one is the bias edge. Okay, so this one is the bias edge. So this edge has its corresponding input and its weight value. This edge has its corresponding input and its weight value. We will multiply the weight value with its corresponding input, this weight value with its corresponding input. Okay, and finally we will add the bias value. Okay, so now let's move to the input H1. So input H1 is equal to 0.10 into its corresponding weight value, that is 0.10 into 0.10, 0.20 into its corresponding weight value, okay, its corresponding weight value, that is 0.20 into 0.20, and finally the bias is 1 into its corresponding weight value is 0.3, so 1 into 0.3. So after the calculation you are getting 0.35 as your answer. Okay, similarly we will do the calculation for H2 input values. Here I have done the calculation for input of H2. Okay, X1 into its corresponding weight value plus X2 into its corresponding weight value W4 plus this is your bias, 1 into bias value is 0.3, so I am getting 0.32, okay. So our two input values for H1 and H2 is calculated. Now the time is to go for calculating the output of H1 and H2. Okay, as I told you, whenever calculating the output you have to make use of your activation function. Here I have make use of my sigmoid activation function, and what is the formula? 1 plus e to the power minus x, 1 divided by 1 plus e to the power minus x. So here you can say the out for H1 is equal to 1 by 1 plus e to the power minus x. In place of x, what you have to put? Input of H1. So input of H1 is equal to, after this calculation, it's 0.35, I will get 0.4133. So I generate 0.4133 as my output of H1 hidden layer. Okay, now I have to generate the output for my H2 hidden layer. After application of the same activation function, I will get 0.4194. Okay, so two things are done. Input of H1 and H2 as well as output of H1 and H2 are all set. Now it's time for the output layer. Okay, now I have to calculate the input for your O1. Okay, so input for O1 is equals to what is the formula? Output of H1. Okay, this is the output of H1 is going here. Okay, output of H2 is going here, this nodes. Okay, out of H1 and out of H2 multiplied with its weight values. Okay, so out of H1 into W5 plus out of H2 into W6. Out of H1 is H2 is your 0.4194 and 0.4133 plus final is your bias value. 1 into bias weight is 0.4, so 1 into 0.4. Okay, after the calculation I am getting 0.5252 as my input value for O1. Okay, now I have to calculate the output value of O1. So out of O1 equal to, same I will make use of my activation function, that is 1 by 1 plus e to the power minus input of O1. So input of O1, and I am getting 0.3716. I am getting 0.3716. But here comes the error. Here the point is to be noted. I am getting 0.3716. 0.3716. Okay, but my answer is, my desired target is 0.99. My desired target is 0.99. I am getting a huge amount of error. Okay, so now I have to calculate my error. What is my error? To calculate the error, the formula is error total is equal to summation of half of target minus output square. Okay, so is equal to half of what is my target? My target is 0.99. 0.99 minus what is my output? What output actually I am getting? Actual output I am getting 0.3716. So when I will do the square and divided with 1 by 2, multiplied with 1 by 2, I will get 0.1911. So this is my error value. This error I am getting when I am doing the first forward propagation. In the first forward propagation, I am getting 0.1911 as my error value. Okay, now there is some error. I have not reached to my target output, that is 0.99. Okay, the error should be not 0.1911. The error should be 0. Okay, now once first time forward propagation is done, I have gone through this forward direction. Now as I am getting an error, okay, my mechanism should be stopped if I have got 0.99, but I am getting an error of 0.1911. Now it's time to again what to do, again move backward. So from here I have reached here, from here again I will move to the backward direction. Okay, why? To minimize the or to make the error as 0. To make the error as 0. Okay, so here what thing in this neural network, what thing I can change to make this error, to get this 0.99 output and make the error 0? What thing I can change? This is the input value, I cannot change. Okay, this will be the input. This is the target value, I cannot change. So what the thing left I can change in this figure? The thing I can change is the weight values. This is the only thing I can change. So now I will backtrack my way. I have just moved the forward way. Now I will just backpropagate or backtrack my way, and I will backtrack the way with changing my weight values. These weight values, okay, W5, W6, W1, W2, W3, W4. Okay, and I will backtrack with changing my weight values. Again I will reach over here. And again I will move forward, again I will go for a forward move, and I will calculate my output. If I will get 0.99, I will stop. But suppose I will get, this time I have got 0.37, okay. Suppose I will get 0.70, okay, 0.70. Still the, the target is not reached. So again I will backtrack with changing my weight values. Okay, again backtracking, I will reach here, again I will move forward, again after backtrack, again I will move forward, and I will generate my output. Suppose this time I generate 0.99, suppose this time I generate 0.99. So now my target has reached, my things are done. Now I will stop the calculation, I will stop the forward backward propagation, I will stop. Okay, so this is the funda of your backpropagation neural network. Okay, now what I will do, I will also explain you about how to change these weight values. How to change these weight values I will also explain you, but that will be in my next video. Okay, so now let's just clean the board and wait for the next video to know how to change these weight values. Okay, so thanks for watching. I hope you like this video. If you like it, then just share the video as much as possible, subscribe to my channel, and thanks for watching.